Behind every creation, engineering processes are required to make that creation reality. These processes are executed by engineers around the world to innovate ideas to ease humans in their daily lives. One such process is the manufacturing process. Before such process can take place, we have to begin from scratch with an idea. This idea leads to a design which is virtually created within a simulated environment. As an engineering student, there will be multiple methods to carry out this design process. So, the big question would be, what are the actions taken to bring such an idea into the real world?
In the current decade, majority of designs start off with a technique, namely CAD, short form of computer-aided design. So what is CAD? It is an industrial art. It is used in so many different engineering fields, and not just engineering. It is even used in computer animation for the spatial effect that we all see in movies such as Lord of the Rings or Jurassic Park, very popular for the animation effect. Well, the reason behind why CAD is popular nowadays is that it has brought such a huge impact in modern design. Imagine someone having a computer and just go and sit down in front of their computer, a few clicks here and there, and voila! They have a robot right in front of their screen. So, as an engineering student, we have dealt with several projects throughout our course, and it always starts with building ideas in mind and then proceed to CAD design to see how the actual thing will work out. The motivation behind this step is that as an engineering student, we always want to finish the project in time, and if we go straight to building after having the ideas and it doesn't work, well, most of the time it doesn't, we'll have to rebuild everything, and it's certainly a waste of both time and energy. Therefore, we start off with CAD, and one of the simple design, like one of our project in mechatronics engineering, is that we were given a technical drawing of a crane chess piece with the dimensions and everything, and we went on to this program called SolidWorks and started clicking on here and there, and as you can see how the sketches are drawn and how we featured it to look even more like a chess piece.
After computer design, manufacturing can be done based on what is virtually designed. Generally, there are two types of manufacturing: manual and automated. From what we know from manual manufacturing, it involves people handling physical tools and machining the parts. But now, with new technologies in this new century, automated manufacturing is generally available for our usage. What is so great about this compared to manual manufacturing is that everything is automated without any human interaction throughout the entire process, except for the programming part, where one has to program the machine to do the required machining. This is called computer integrated manufacturing. Programming such a machine is not just using any conventional programming language that we have come across. This specific programming is called CNC programming, Computer Numerical Control Programming. Programming for control of this particular machine involves how the tool moves across the workpiece and also setup for the machine, such as where do you want to put your workpiece, where the tool initially is. One of these added advantages using CNC programming is the simulation of machining, from every single step of the machining to the estimated time taken for it to machine a single piece. This is crucial as it can help to prevent material waste. It also saves time and the cost of material. We can predict any errors by looking at the simulation, that we can avoid wasting energy and time from making multiple trials of machining just a single piece. This can save a lot of time and trouble, and we can use this method to make our life easier and complete our tasks in time.
So now I'm going to introduce the two machines used in manufacturing. The first main machine is called the milling machine. The facility we have here is a CNC machine. It is an automated machine that uses an automated door. The automated door is controlled by pneumatics. So from there, you have to know that the chuck itself is movable in all three directions in all X, Y, and Z. Now the horizontal placer is actually movement in horizontal direction only, means back and forth. And you have also to know that there's an air gun inlet where it enables you to put the air gun there to wash off all the dust and everything. So now I'm going to introduce the second machine, which is a turning machine. This turning machine is an automated machine. The lid is automated, so you don't need to use your hands and lift it up. Now, what you also need to know is the pressure bar at the side is crucial so that you don't exceed the pressure. Now, there are two compartments that you must take note of, which is the chuck and the tailstock. To put the material in the chuck, you must first unlock it using the Allen key. Once unlocked, place it securely in the chuck and fasten it using the Allen key. Then, once it's done, you can program the code to move the tailstock away or back to the front to start your process. Keep in mind that the chuck is the one that rotates, not the tailstock. So do not come in contact with the chuck or the material while process is being done. Once the process is over, move your tailstock away and unlock your chuck to retrieve your workpiece. Keep in mind that this is an automated machine, so no human intervention is required.